Okay, guys, in this video, we are going to start talking about computing probabilities associated with normal random variables. And first, we're going to look at standard normal variables. So it used to be that we actually use tables for this sort of stuff, for computations, for probabilities. But nowadays, we have computers, so we're just going to do that. I don't see a reason to also learn the tables. If you have to, if in another course they're going to force you to do it, I guess you do it. But overall, nowadays technology is so far ahead that we don't really need the tables. But I do want to spend a little bit of time on actually computing probabilities associated with standard normal, because this is something it's like instructive, I guess. And then we're gonna look at the general normal case. So standard normal random variable has mean 0, so you can see that the distribution is centered at 0. And then the standard deviation, this is where the inflection points of the curve happen. That's like one standard deviations away from the mean. So that would be at 1 and at -1. So that's where the curve bends, okay? So we want to find some probabilities. So let's say they want us to find what's called a less than probability. So we have some standard normal random variable. Usually it's denoted by z. So that's just a kind of customary thing. So whatever it is, it's something that has a standard normal distribution. And we want to know what's the probability that something is less than 1.28. So for example, and this 128 is called the z-score. Okay, so let me show you how you would find this in Desmos. So I have a Desmos calculator here. So this is normal distribution, right? So what we're going to do is go to keypad. On the bottom of the keypad, we will see functions. So click on functions. Then we're going to scroll down to where it says distributions. Okay, so we'll choose that. And then you can see that there is normal distribution there. So I'll click on normal distribution. Now, by default, it tells me that the mean is 0, standard deviation 1. So by the way, if you ever forgot what is the mean and standard deviation of standard normal distribution, Desmos actually tells you that. Now, it also will graph it for you, but the graph looks kind of weird because the scale is off, right? So basically what you want is, because the standard normal random variable basically is only there from about -3 to +3. That after that, it pretty much dies down and it's almost 0. Okay, so I want to find the probability of being less than 1.28. So now you have to understand something. Okay, so if you have probability of being less than 128, how does that look like in interval notation? So from algebra, you need to know, let's just say that's the real line, right? So 128 is somewhere over here. You're talking about less than that, right? So you are looking for an interval that would start somewhere over here and go all the way to 128, right? And so that interval in interval notation can be written as -infinity to 1.28. Okay, so the upper bound of the interval is this number. So anytime when you are finding probability of less than, you want the upper bound, which in Desmos will be called the maximum. That would be 128, and the minimum would be -infinity. So the minimum, actually, you can just leave blank, so you don't even have to put anything there, right? So first of all, check the box that says find cumulative probability. Like I said, leave the minimum -infinity, because you want all the way from -infinity up until 128. And then this you change. Just type the maximum 128. Now, the good part about Desmos is it not only computes the probability for you, but also shades it. So you can see that that total blue area is 0.8997, which should make sense because the total area under the curve equal 1. And that is definitely not 1. There is still some part that's not shaded, right? So this is a left probability, so less than probability. Okay, so for less than probability, you will be using minimum -infinity, maximum 1.28. So another example, let's say I wanted to find probability. What about z less than, let's say, -0.676 or something like that? Okay, so same thing. The interval will start at -infinity, so the minimum will go at -infinity. The maximum will be -0.76. So all I have to do over here is just change this number to -0.76, and it also will update the area for me and give me the answer. So the answer is like 0.2236. Okay, so now let's look at the second case. So this was like case 1, which is like we will call that less than case. And now let's look at case 2. So case 2 is greater than. So usually, by the way, it doesn't matter whether it's greater than or equal to, it's going to be the same area, makes no difference. So I can put more than or equal to will not change the answer. So let's say I want to know what's the chance, for example, that standard normal random variable is greater than 2.12. So if I draw a picture, and 2.12 is anywhere there, so I'm not drawing it to scale. So just put it somewhere. And I want to be greater than that, right? So if I want to be greater than that, I'm going to shade all of this to the right of 2.12. So now in interval notation, this would look like this: 2.12 comma infinity, because you're starting over here and then infinity is somewhere over there on the right, right? So in this case, minimum would be 2.12 and maximum would be infinity. So what do you do on the Desmos calculator? This time, change the minimum to 2.12, right? Oh, I can't remember what I just said. Yeah, 2.12. Okay. For the maximum, just delete it and leave it blank, because that automatically just changes to infinity if you leave it blank. And Desmos shades it for you and tells you that that's approximately 0.017. So that would be your answer for that area, right? That would be 0.017. So another example, what if I wanted to find probability that z is greater than, let's say, negative 1.86 or something? Okay, so same thing, it's greater than. That's when we say the minimum set it to 186 and the maximum would be infinity. Okay, so for greater than, for case 2, you always set the minimum to be whatever the number they give you, and the maximum is leave it blank. So here I have negative 1.86, so I'm gonna set that here and leave the other one infinity. It tells me that the answer is 0.9686, something like that, right? So that would be the answer. Okay, so let's look at the last case, which is case 3, and this is what we call between probability. So this is even easier. So for example, I want to know what's the chance that z is between negative 2.13 and, for example, 0.36. Okay, so this is between, very easy, because this is your minimum and then this is your maximum. So whatever they are now, you don't have to worry about the infinity, whatever, right? So let's go ahead and put them in there. So I'm just gonna have it side by side with the Desmos. So for the minimum, we put negative 2.13. For the maximum, we put 0.36. It shades the area for us, and it tells us that this is 0.6240, I guess, if you round that. So if they change it, give you different numbers. So let's say negative 1 to positive 2 or something like that. We'll just change the numbers right there, and then so that's going to give you the answer. So I think the between probability, nobody usually makes any mistakes. It's usually the left and the right part that people don't understand. But again, think about that. If I want to be less than something, that something is my upper bound. I cannot get higher than that. So I'm less than that. So I go from negative infinity to that something. If I want to be greater than something, then the lower bound under me, like I cannot be lower than that, right? So I start with that and then go all the way to infinity. So if you think about it like that, hopefully you're not going to make mistakes when computing normal probabilities.